Division of a line segment. Today in this video, we will learn to divide a line segment in a given ratio. Look at this line segment AB here. Can you divide AB into two equal parts? In the previous class, we learned how we can construct a perpendicular bisector of a line segment, which divides this line into two equal parts AM and MB. Can you tell that the point M divides the line AB in what ratio? Absolutely correct. Since AM and MB are equal, hence point M divides the line AB into ratio 1:1. Now if we want to divide the line AB into four equal parts, then what shall we do? Well done. We can take the help of perpendicular bisectors to do it. Here, AP, PM, MQ and QB are four equal parts of the line AB, where point P divides the line AB in the ratio of 1:3. The point M divides the line AB into 1:1. Can you tell the point Q divides the line AB in what ratio? Well done. This point divides the line into 3:1. From this process, we can say that if we divide a line segment into 1:3 or if 3:1, then we must first divide the line segments into four parts. Now, if we want to divide the line segment into 5:3, what do we have to do? What do you understand by dividing the line into 5:3? This means that we have to divide this line into 8 equal parts. Also, we have to find a point that divides the line segment into 5:3. It will be difficult to do this, and there are more chances of mistakes in this method. We have another simple method of dividing a line segment in the given ratio. Let's see. For this, again the line AB will be considered. And on this line, draw an acute angle MAB. Now, the ray AM will divide into 8 equal parts. Can you tell why the 8 parts are made here? Because we suppose we have to divide the given line segment into the ratio M:n, the sum of which, that is, the sum of ratio tells us that into how many equal parts of a ray making a low angle is to be divided. As here, the line AB is to be divided into 5:3, whose proportional sum is 5 plus 3 equals 8. Can you tell how will we divide it into equal parts? For this, we can make use of a compass. Let's see how we can do it. In the compass, take an approximate radius of 1 centimeter. Without changing radius, on the ray AM, mark 8 arcs, that is, A1, A2, A3, A4, A5, A6, A7, A8 respectively, so that AA1 equal A1, A2 equal A2, A3 equal A3, A4 equal A4, A5 equal A5, A6 equal A6, A7 equal A7, A8. Now point A8 and point B are to be connected to get line A8B. Since we are dividing the line segment into 5:3, from A5 we can draw a parallel line to A8B. To draw a parallel line from point A8 and point A5, draw an arc of equal radius. Now on the angle AA8B, using the compass, another arc is drawn on this arc, from which we get point X. Now let's connect point A5 and point X. We further extend the line A5X so that it intersects AB at P. So in this way, we get a point P, which divides the line AB into 5:3. Can you tell how it is possible that by dividing another line, we are able to divide the given line in the same ratio? Let's see how. If the triangles ABA8 are focused upon, the lines BA8 and PA5 are parallel to each other. Now, from the basic proportionality theorem, we can say that AP upon PB is equal to AA5 upon A5A8. Since AA5 over A5A8 is equal to 5/3, so 5/3 is equal to the figure, therefore AP upon PB will be in the same ratio. So we can say that point P divides segment AB into 5:3. In this way, it is proved that by this creation method, we are able to achieve the desired division. Today in this video, we learned about dividing a line segment in a given ratio. In the next video, we will study another method of this concept. Welcome all of you to this video. In the previous video, we studied a method of dividing a line segment in a given ratio. Today we will learn about another method of dividing a line segment in a given ratio. You may remember that in the previous video, we divided a line segment into 5:3. Let us now divide this line again using another method. We have to divide this line AB into 5:3. For this, firstly, from point A, draw a ray making an acute angle. Let the ray be AM. And parallel to ray AM, draw a ray BN from point B. You may remember that we also learned to draw two parallel lines in the previous video. Now, on ray AM, mark 5 arcs of equal radius. Now, on ray BN, mark 3 arcs of equal radius, which are named A1, A2, A3, A4, A5 and B1, B2, B3, respectively. Connect points A5 and B3, which gives the line A5B3, which intersects line AB at point P. And the point P is where the line segment AB is divided in the ratio 5:3. Can you check the validity of this method? If in triangle APA 5 and triangle BPB 3, angles A5, AP and angles B3, BP are equal and angles APA 5 and BPB 3 are equal. So from AA criteria, triangle APA 5 and triangle BPB 3 will be similar. And we know that the corresponding sides of identical triangles are mutually proportional, from which we get the ratio of AP and PB5 ratio 3. So we can say that point P divides the line AB into 5 ratio 3. Today we learnt another method of dividing a line segment in a given ratio. Hopefully, you have understood both methods well. Division of a line segment. In the previous videos, we learned to divide a line segment in a given ratio. Today, we will see interesting examples based on this. By joining the points dividing each side of the square ABCD into 1:3, do you know which shape will we get? Let's first divide the arm AB into 1:3, for which from point A, an acute angle forming ray AX is drawn, in which 4 equal arcs A1, A2, A3, A4 are made. Can you tell why we made these 4 parts? Absolutely correct, because here the proportional sum is 4. Now point A4 and point B are to be connected, which gives us the line A4B, to which from the point A1, a parallel line is drawn which intersects the side AB at M. Similarly, we divide the sides BC, CD and DA in the ratio of 1:3, from which we get the points N, O and P respectively. Joining points M, N, O and P, we get a quadrilateral MNOP. Now, can you name this quadrilateral? If we use the scale with the sides of this quadrilateral and measure all angles with the help of a protractor, so we find that all the sides of this quadrilateral are equal and all angles measure 90 degrees. Hence, quadrilateral MNOP formed here is a square. So now, can you tell? In an equilateral triangle, rectangle and trapezium, when the points dividing the sides in 1:3 are connected, what shapes will we get? Pause the video and match your answer later. When we do that, we get an equilateral triangle inside of an equilateral triangle, parallelogram in rectangle, and a trapezoid is found in trapezium. Hopefully, you have now understood the division of line segment in a given ratio perfectly.